Hello, my name is Fatima Najoui, researcher at School of Architecture, Planning and Design at Mohammed VI Polytechnic University. This project is under a research program about the integration of renewable energy in the building. The project took place in the context of Benguerir, specifically it's a study of some passive solutions integrated to residential building using multi-objective optimization. This topic is actually closely linked to the energy efficiency in buildings. Firstly, I'll introduce the context of the study and the methodology followed in this research. Following this, the results of the optimization that allowed the material choose and simulation result to minimize the heating and cooling needs. To optimize the building in Benguerir, the following methodology was used. First of all, based on a general literature review that was concluded on the optimization of the buildings in a semi-arid region, the DesignBuilder software was selected for this study. Secondly, preparing a prototype for the buildings and its properties are specified: total surface, openings, layout, and geographical positioning. Then, two optimization studies were conducted in order to define the optimal parameters for DesignBuilder simulation. Lastly, different scenarios were proposed in order to minimize the cooling demand. Each scenario is actually a passive solution. The house is situated in Benguerir, a region which is under the 5th climate zone of Morocco, known to have a semi-arid climate. The region has high temperatures in summer with a very dry climate throughout the year. The case study is a simple courtyard house composed of a ground floor and the first floor. It has a south orientation for living room and bedrooms, as well as west and north orientation for the kitchen and bathrooms respectively. With the results of the optimization, a simple combination of the construction material had been made with the use of the clay, and then initial simulations was conducted in DesignBuilder software. The first concerned the choice of the material combination in accordance with the cost and CO2 emissions. The second one dealt with the openings and the blends used in order to minimize the heating and cooling needs and the cost in general. The result of the optimizations showed that the clay or earthen material provides natural insulation. The second one showed the importance of the shading and double glazing. The initial simulation shows a significant annual heat gain by the windows. It also highlights the cooling needs that can reach 111 kWh per meter square per year. Other simulations were carried out in order to minimize the cooling needs. Each simulation was an additional solution, such as insulation, shading systems, and then the use of Mousharabi. The results were compared in terms of heating and cooling needs reduction, CO2 emission, and the cost. The last passive solution was in addition to the insulation, Mousharabi system that covers the south and west facade of the building with 1 mirror space of air circulation. The system was deemed the most effective by simulation in order to minimize significantly the cooling needs with a total that is less than the required value by Moroccan thermal construction regulation for the Benguerir zone, which is less than 61 kWh yearly. And thank you for your attention.